All right, so in Python, if you use like a SignPy, there's a curve fit. Just declare the function and the variables, write the function there, and then they automatically do the least square thing for us, like writing the huge matrix. Okay, so that is my solution. Again, the 2 decimal places will be fine. So also here, the dashed black line is the model, and then the blue curve is the actual data there. Okay, so basically the second question asking us to find the coldest and the warmest day. So I'm writing a model for the 2 years. Okay, so you can say it's from 0 to 730 days. Okay, then I mean that's easy. So just find the minimum and the maximum for this function. So basically my maximum is 202, a 3 day. So the 203rd day of the year. So you guys convert it, right? And then my coldest day is January 20th, something like this. Okay, then that's for part 2, right? So for part 3, as I mentioned, so we are going to use a different model. So I'm using ABC, the old model, plus dx squared. So my variable is called x. So you can call it a k. It doesn't matter. So then same kind of trick. Okay, either using Python or MATLAB. Later you will get a file there. Okay, then that is a new model. So I hope this is sort of clear. We are seeing a gradually increasing function here. Okay, over the years. So basically that's evidence for global warming. That's like Detroit weather data. Okay, all right. So this is everything for question 1. So then I will briefly go over question 2 real quick. All right. So then firstly, we always have to clean the data in pod. Okay, I only included the useful data. So basically the first column is the time. Okay, you can look at your table. So basically this is like 0.1 second, 1 second, and then like around 10 seconds. So the middle column is the position for bot. Okay, the third column is the position for Thompson, I think. Okay, but anyway, use the correct data to fit your model. Okay, so then let me point out that my model is basically the following. So my model says those guys are traveling in 0.5 of or 1 of the acceleration. Okay, then like 8.3 initial velocity minus 1.7 the initial position. Okay, that's my model. It's basically the same for Bolt and Simpson. So basically, that's sort of inconsistent with our actual physical picture, right? So, I mean, we should start at 0 and traveling in a relatively low velocity and not constant acceleration, right? So basically, that's saying that we are not choosing a perfect model. Okay, our model somehow isn't telling the truth. Okay, let me know if you have any questions. All right, if you already compute that your answer doesn't agree with mine, you can let me know. Okay, all right. Anyway, so basically that's for part 1 of problem 2. Okay, then I'm just trying to plot the picture here. Okay, anyway, so then that's a lot of plotting. So this is question 2 part 2. I'm trying to fit only the first 5 entries of my data. So you can see the first 5 seconds is roughly the first 5 or 6 entries from your table. Okay, I'm only using the first several seconds. Then I got a much better model. Okay, my model says I roughly have a constant acceleration still. Okay, like 2.4 t squared. Okay, and then plus 3.8 or something. 3.7. Okay, t, and then minus 0.12. That is much better, right? So basically a relatively low initial velocity and then a almost zero initial position, right? So that's much better. Okay, so any questions on this part? Okay, you can put some explanation there. Like the actual physical picture looks like this. The first 5 seconds is the acceleration part, and then the later 5 seconds is the constant speed part, right? So we cannot use the acceleration part to fit all of that. So only the first 5 seconds work well. Okay, so then that's about everything for problem 1 and 2. Use your own data. Okay, my suggestion is you can try to do something that's unreasonable to say what's going to happen for linear regression. For example, my work is like fitting the stock price of Microsoft. Okay, I basically took the blue line is the stock price for Microsoft from 2000 to this year. Okay, and then I'm using a polynomial of a relatively high degree to fit that. Okay, still doing this square. And then there's some ridiculous result, like the stock's price is growing surprisingly high, in the next 3 years, which is apparently not true, right? So basically, the idea for this set of questions is telling us like least square data fitting is useful in some circumstances, but not everywhere. Okay, if you choose the wrong model, there could be some ridiculous conclusion. Okay, so that's the idea. All right, so then I'll actually stop sharing and stop the recording. Okay, so I'll actually work on this project, and maybe you can talk about that. I will also share with you some MATLAB file, okay, so that you can facilitate your collaboration with your peers. So any questions so far?